Okay, hi guys. This is the chapter 6 review. I wanted to just go over each problem, that way you've got it as a resource if you need to do retake or whatever on the chapter 6 test. So this is the review, exponential functions. Here's the first problem. These will be drop-down menus when you get into Canvas itself. But just a couple things to remember here. Exponential was our big idea for this chapter. This was the new term. That's what gets big in a hurry. If you remember, the penny a day doubled, turned it into millions of dollars. As opposed to what we used to do down at the bottom here was linear. Linear means it's growing at a constant rate. It's typically an add or subtract idea, but it's a straight line, okay? Exponential is going to curve and get big in a hurry. Explicit is the one term that we're talking about wanting a formula for. That's a formula to get any term in a sequence, okay? Geometric and arithmetic, those are both sequence terms. Geometric means we're going to multiply to get to the next term in a sequence. Arithmetic means we're going to add to get to the next term in a sequence. So that's the first problem. Problem number 2, right here says, which of the following equations represent an exponential function? On these, as we talk exponential, we just want to look for an exponent that has an x with it. See letter D right here? That's the only one that has an x for an exponent. That is the format for exponential functions. So the rest of those don't even matter. That's what we're looking for. X is an exponent. All right. Number 3. The general formula, here it is, y equals ABX. The test could be any question. This one's asking what does B represent, but let me just line that out for you, okay? A is your y-intercept, okay? That's where it crosses the y-axis. So that first number is going to tell you where you're starting. B is your common ratio. And in terms of an exponential function, that's what we're multiplying by to get to the next step, okay? And x is merely your exponent. That's always going to be an x. That's how geometric equations work, okay? So that'll do that one for you. Okay, number 4 says evaluate when x equals 5. All that simply says is take that 5 and plug it in for x right there. So it now reads 1/4 times 4 to the 5th power. And all you got to do is evaluate that. 4 to the 5th power means 4 times 4 times 4 times 4, 5 times. That answer is 1024. And then I've got to multiply it by 1/4 or divide it by 4, which you end up with 256 is your answer. Number 5. Which equation matches the graph? Again, we're talking exponential growth again. Here's that get big in a hurry idea. This is a multiplier to get to the next step. Remember that our general form is y equals ABX. The A is the y-intercept. You'll notice the y-intercept is 1. Okay, the B is our common ratio. Now, as I look through these multiple choice answers, I know 2 things real quick. A and D can't be the answers because we have a common ratio of 1/2. 1/2 is actually going to take our graph and make it fall. It's going to get smaller in a hurry, okay? So it can't be those 2. It can't be letter E, okay, because E doesn't have an exponent of x. That's not even an exponential function, so that doesn't work. So that narrows us down to B and C. Now B can't be it because that's crossing the y-axis at 2. That's not what we have here, it's 1. So you could think of this one right here as having a 1 out front. 1 times 2 is going to be our common ratio. Letter C is what I'd be looking for in that question. Okay, number 6. Number 6, you're buying a car for $25,000. It's going to decrease in value. The big key here is if I have 100% value and it's going to decrease 1%, that means it's worth 99% now. So you'll notice letter A here is the only one that deals with 99%. They all have the form of Yart, if you remember. A is your initial amount and R is your interest rate. We're using 99% because it lost a percent of value. So this would be the appropriate formula for that problem. Number 7. Now they're saying, let's go ahead and figure it out. Now in this case, we are decreasing in value, so this is 25,000 is our initial rate. We're decreasing by 1%, so we're going to use 99, and we want to know in 5 years' time. So we're going to go ahead and punch that in our calculator. We want 0.99 raised to the 5th power times 25,000. Make sure you do the exponent thing first, then multiply by 25,000. And when you do that, you should come up with the 23,775. That's what that'll translate to, okay? Number 8. This rare artifact is 73,000 right now. It increases in value at 3%. So if I have 100% value and it increases 3, we're now at 103% value. So I take my initial amount and it's going to increase by 1.03 this time. Remember, it's got to be bigger than 1 if it's going to increase. And then we've got a 10-year span that we want to know about. Simply do 1.03 raised to the 10th power, and then multiply by 73,000. And when you punch that in your calculator, you should get your 98,000, about 98. It's going to be like 98,105.89 is what your calculator will probably say, but that's very, very close, or about that. Okay, number 9. Number 9 simply has some dots here, and it's asking us to describe the graph. Well, from what I can see from the dots, they're not a straight line. This is that same gets big in a hurry idea. We start out really small and then we gain quickly. That's an exponential idea. That's as simple as it is. It's not a straight line. It's not a circle. A parabola is a smiley face type thing that does this action. Okay, but that's what we call exponential. That's the very thing we're working on all chapter here. Okay, number 10. Which statement best describes the table? As I look at this table, f of x is our y values. I'm noticing the pattern here to get from one to the next is a +3. Over here, the same pattern is a +1. This +3, this is where I want to focus. If that's an addition, that's going to jump me right here to linear. That was right out of our number 1 question. Linear, remember, is to add or subtract, and it's going to give us a straight line when we plot these points. If this were a multiply, it would be exponential. So this is a great example of a linear function. Number 11. Again, what best describes this table? Well, if I look at the pattern going here, now this time we have a multiply by 2. All of a sudden we've changed to a multiply scenario. That's the whole idea with exponential. That's the very foundation of what this chapter is about. That's the key with exponential. When I see these y values going a multiply, that's what we're talking. It's not linear anymore. It is a function, so that's not correct. A function just means all these x values can't be the same, and they're not. But exponential is our idea, because it's a multiply. Number 12. What are the next 3 terms? Well, I'm looking going from 3 to 6 to 12 to 24. It looks to me like we're doing a multiply by 2. This is a sequence. We're multiplying by 2. So we just need the next 3 terms. What are they? Well, 24 times 2 is 48. 48 times 2 is 96. It's going to be these 3 numbers right there. We're simply going to keep the pattern going. Number 13. What are the next 3 terms in this sequence? Well, I'm going from 1 to 5 to 9. If you'll look that through, that's a +4 idea. And so if I want the next 3 terms again, 13 plus 4 is 17. 17 plus 4 is 21. And so forth. And that's how we get this answer right there. Again, we're just going to follow the pattern. Number 14. Explicit equations. I don't know if you guys will remember this, but this is our general form. We want to take a sub n. That means whatever term we want. We're going to take the first term, and we're going to multiply it by the common ratio, and then do a power of n minus 1. That's the general form. So in this particular case, the first term happens to be 2, so I'm going to do 2 times, and then what am I doing to get from one to the next? Looks like that's a multiply by 3, so I'm going to go 2 times 3 raised to the n minus 1. That's going to get you to letter B right there, okay? Number 15. We're almost done here. Which sequence represents the recursive? I remember I told you guys recursive is, we just want to be able to translate what this Greek means, right? A sub 1 means the first term. That means the first term in this pattern is 4. What do I do to get to the next term? I simply add 2. So I will get 6, then 8, then 10, then 12, and that's my pattern. That's going to lead you to that answer right there, okay? Number 16. Find the 18th term. This is a geometric sequence. That tells me right now I'm thinking multiply. And if I look at the pattern here, it looks like it's a multiply by 3. If I want the 18th term, remember we're going to take the first term, which is a sub 1, times it by the common ratio, which is 3, and then to the n minus 1 power. So if I want the 18th term here, that means I'm doing a to the 18th. I'm going to do the first term, which is 1, times 3, because that's my common ratio, and then it's n minus 1. If I want the 18th term, I got to do 18 minus 1, which is 17. So I'm going to do 3 raised to the 17th power times 1. And when you do all that, you will get your multiple choice answer will be there somewhere, but you're going to get 129,140,163. That's going to be the answer when you punch that in. It's 3 times 3 times 3 times 3, 17 times. Okay, and so there's the answer we're looking for. And finally, our last problem. Find the 30th term in the arithmetic. Now arithmetic, our general formula that I gave you guys was, let's take the first term again, but this time arithmetic means to add, and you'll notice to get from one step to the next, I'm adding 3. Now we could sit and add 3 30 times and get there, but the formula says just take the first term, add it to 3 times n minus 1. So if I want the 30th term, I'm going to take the first term, which is 1, add 3 times n minus 1. Well, if I want the 30th term, I'm putting a 30 there. 30 minus 1 is 29. I'm just simply going to do 3 times 29 plus 1. And when I do that in a calculator, I'll get 88 as my answer. And there it is. Hopefully that'll help you. That's just a general description for each problem you'll see. When you get to the test, it'll be very much like that. Good luck. Have a good day.